Hello, everybody, and welcome to another episode of Advent of Code in Kotlin 2025 edition. It is day 2, and I'm very excited to be back. We've had a nice little warm-up yesterday with Martin, where we did our first little puzzle here in Kotlin, and saw a couple of quite interesting things, including pretty neat visualization. Make sure if you haven't seen that yet, after this stream, you can check that out. But of course, thank you so much for tuning in, everybody. If you are in the chat, either on YouTube or on Twitch, where we are also streaming, make sure you drop us a line, say hello, and most importantly, I'd like to already get some idea of how you felt about today's problem. Did you think it was difficult? Do you think that we can already feel the compressed difficulty curve? Because, as we know, this year's Advent of Code is a little bit shorter than usual. Let me pop myself over here, perhaps, because indeed we can see here that starting this year, we'll have 12 days of puzzles each December. No, it's not the 24/25 of the previous years, but there's still a lot of interesting things happening. As a corollary, it also means that us going from day 1 through day 5, that's where we will be doing the live streams, I would predict that we would still see quite a variety of different problems within that section still. We're getting the first couple of opinions here. Today was easier than yesterday. Yeah. Getting a lot of hellos, people tuning in. I hope that you did arrive at a good solution in the end, though. And of course, this is probably the ideal place to once again advertise that we aren't just doing streaming. In fact, there's a little bit more. For example, our leaderboards and our overall campaign. To those of you who are sensitive to light, quick warning, I'm going to switch over to a tab that's comparatively bright, which is our blog post that tells you all about our Advent of Code 2025 campaign. That, of course, includes the videos, but it also includes our lovely community in the Kotlin Lang Slack, our community leaderboards that we have, and, of course, our Advent of Code GitHub template that allows you to start quite easily. And if you want to try our build system Amper as an alternative to Gradle, also allows you to get quick started with that as well. Well, we can see that the initial commit was 4 years ago, so we've been going with this stuff for quite a while. Even if you're not getting up super early and racing for some top spots on the leaderboard, it is still worth participating, because by following the instructions that we have here, you still have the chance to win some exclusive Advent of Code swag, like perhaps a shirt or a mug or whatever else might be out there. So make sure you check this out. Yeah, have a look. Yeah, I was not kidding about the brightness here. Don't worry, we'll go back to the slightly cozier looking Advent of Code page here, and maybe by some point we'll figure out a way to get our JetBrains blog in dark mode too. But still, we have a small mention of Kotlin by JetBrains here as well, because we are proud sponsors of Advent of Code this year, like previous years. And I'm also personally a subscriber to Advent of Code Plus, because I think it's really cool and it's really worth supporting. Seems that we're not seeing so many sneaky off by ones today. That's already great. Very good. Very exciting. Well, I think there's enough meta discussion for one day. It's time to meet today's guest. So I'm very, very excited to introduce. Here we go. Dave Leeds. Dave, good to have you here.
Hey, thanks so much. Good to be here.
I mean, you are by now effectively, I think, a core part of this wonderful tradition that is Advent of Code in Kotlin. So I'm very excited to have you back.
Yeah, thank you. I think this is the 4th year that I've gotten to be on here. So I really appreciate you asking me again.
Yeah, absolutely. No, it's always a good time going through these puzzles with you. And debating. I think we have a great way of diving into all the nitty-gritty and maybe doing a little bit of bike shedding here and there as well when it's fun. Yeah. So from a timing perspective for you, do you typically do you try to go for, well, there's no longer a global leaderboard, but do you still try to do the tasks when they come out, or are you doing them in your own time?
Yeah, typically it's in my own time. And there are a couple of reasons for that. One is that I'm simply not a very competitive person to start with. But also the time zone that I'm in here is in Nashville, Tennessee in the US. And so it actually becomes available, the puzzle becomes available for us here at 11 o'clock p.m., which is normally, I'm already drifting off to sleep by then. So it's always a little bit of a decision of mine, especially when I'm going to join you for the live stream, as to whether or not to stay up late and try to get the puzzle done at night before I go to bed, or sometimes I just read what it is and hope that my brain will kind of process it while I'm dreaming and sleeping, or just wake up super early and try to crank it out first thing in the morning. But this time I actually took care of it in the evening, so I stayed up a little bit later.
I personally would argue that that's maybe the extra difficulty level, because when you're fresh in the morning, I always find it a little bit easier to tackle these kind of problems, whereas there have been moments in late at night where I'm not ashamed to admit that I thought I came up with a really, really clever solution, and I realized I had just reinvented a hash map from first principles because I was just so laser focused on something.
I've been there. I've done the same thing where I think my solution at after midnight is just the best thing ever, and then looking at it with a fresh cup of coffee in the morning and oh no, this is not good.
Yeah, no, I can definitely feel that. I'm currently I always use Advent of Code to kind of stabilize my sleep cycle, because while I do tend to go longer in the evenings typically, I find it very nice to also be up and ready and productive from the get-go, which is always quite a delight.
What time does it come out for you where you are?
6 a.m.
Okay, yeah, so you get up nice and early to start the day off with a good Advent of Code puzzle.
I'll let you in on a secret here. I currently get up at 4 a.m. actually.
Wow.
just to really really stabilize this entire part. It just also allows me to get some other stuff done beforehand. I used to have a setup where at 5:55 my alarm would ring and I would just do it in bed half groggy. But now I can do my entire morning routine, and I can sit down with breakfast and get into things. It's a little maybe a little crazy, but it's at least for these kind of things, it really works out well for me.
Yeah, better focus, I think, once you have gotten your morning routine worked through before you start the puzzle.
Oh, absolutely. All right, well, lots of discussions here. I think it is time for us to put the hats on. Did you bring a hat? Oh, you brought a hat. What a delight.
The question is whether I can get it on with the headphones. I think that'll do.
Amazing. Very good. Ah, that's a great look. That's an amazing look. Okay, I will move us into a corner where we don't cover the text, and we will get started with day 2, gift shop. You get inside and take the elevator to its only other stop, the gift shop. "Thank you for visiting the North Pole," gleefully exclaims a nearby sign. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here. And from there, you can access the rest of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you'll need to check. For example, 11 through 22, 95 through 115, 998 through 1012, and a couple of much larger ones. The ID ranges are wrapped here for legibility. In the input, they all appear in a single long line. The ranges are separated by commas. Each range gives its first ID and last ID separated by a dash. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. So 55, 5 twice, 6464, that's 64 twice, and 123, 123, so 123 twice. Those would all be invalid IDs. None of the numbers have leading zeros. 0101 isn't an ID at all. 101 is a valid ID that you would ignore. Your job is to find all of the invalid IDs that appear in the given ranges. In the above example, between 11 and 22, we have 11 and 22. Between 95 and 115, we have one invalid ID, 99. Between 998 and 1012, we have one invalid ID, 1010. And then for those larger ranges, we get things like 11885, 11885. So that's this sequence repeated twice. In this range, we get a whole bunch of 2s. Doesn't really matter how we look at them. That's 3 2s. That's another 3 2s. Then 446, 446 in this range, and so on. Adding up all the invalid IDs in this example produces a large number. What do you get if you add up all of the invalid IDs? Okay, very good. Dave, what went through your head? Tell us.
So when I first read this puzzle, I was kind of concerned about how large the numbers and the fact that we had ranges for them. It made me kind of wonder if the challenge was going to be, like, sometimes the challenge, especially in the second half, is going to be something regarding the magnitude of the data that you're working with. And so sometimes the more straightforward approach doesn't always work. So I think that was kind of what was most concerning to me when I read this, was just like the large size of the numbers and the fact that we had ranges for them.
Yeah. Like really, and looking at them, I am. It's quite hard to tell just by squinting how big these ranges already are, right?
Right.
Like how those seem to have the same number of digits, but who knows what might exactly be the way. But yeah, okay. So then I guess I think it's a great time maybe to switch over to your screen.
Yeah,
and
sounds good.
We'll take a look at your solution. Let me just pull up your screen over here.
Okay.
There we go. Wonderful.
Yeah.
Great. So, please.
So the one of the things that I've always learned is that even when I feel like the brute force approach might not work, it's almost always been worth it for me to take the time to do that anyway. Like, just to try to go with the most straightforward solution that I can. And a lot of times that just kind of keeps things a little simpler and only advance to the more complex or situation where I need to have the mathematics of it figured out just right, only if I really need to. But no matter what it is I'm doing, the first thing that I almost always need to do is to parse the input in some way. So I guess, do I keep the hat on? Do I keep the hat on? I don't remember.
I mean, honestly, we can keep it on.
Okay, yeah, it's nice and warm. So
yeah,
okay.
exactly. Until our brains like overheat, then we don't want to take them off. But why not? We're going for it.
Sounds good. So so the first thing I did is focus on parsing. And when I started parsing this, really we've just got a list that's a comma separated list. And then we've got, it was really a list of ranges. So my first take on this was actually to just map to an actual long range. So this was actually returning originally a list of long range. But then I kind of realized that I really don't need to operate on the range per se. I really just want each individual item out of the range. And so that's why I did a flat map. So the flat map is actually going to take the long range and take all of the values all along the way and kind of put that into one list for me so that it's ready to go. So let's open up part one. Let's see here. Now, like you said, one of the first things that occurred to me was that I really want to know how many values am I dealing with, because I was a little intimidated by the size of the numbers and I wasn't really sure if you actually take the number of values out of these ranges, how many are we dealing with? So you can see that was the very first thing I did once I parsed the string, was to just print out the size. And thankfully it was a manageable size. So I realized, okay, I can probably move forward with a very straightforward approach. So I just made a mutable list. I'm not doing this in a very functional approach. This is really just a very straightforward imperative approach here. So I turned it into a string. So I've got them in as longs, and we know that should be okay because they told us that there won't be any leading zeros, so we don't have to worry about that. So I took them in as longs and then converted them to a string here. So that's what ID string is. This is probably something that most of us see very frequently, and that is just telling whether or not it is an even number of digits. Because in this one, it was only going to be half and half. So if you had 3 digits, it didn't matter here. So, we just take the first half and we get the second half and just compare them to see if they're the same. And if they are, then I added them to our little list. And at the end, I just returned the sum of those items. And that was about it.
Seems pretty straightforward. It's interesting that you're using .rem here, especially to everybody who still carries a little bit of trauma from yesterday's mod and rem debate.
Yeah.
Did you specifically pick rem here over the operator for clarity or personal preference, or
for really no particular reason? It was really just because that was the one that occurred to me, and I remember yesterday also talking about I guess the negatives are affected in certain cases and things. But yeah, I just went with rem just because that's what came out of my fingers typing on the keyboard. That's just what happened.
No, very, very good. I think this is a pretty straightforward approach. There is one question here, which is what is .rem? That is the same as using the percent operator, which is the remainder, which is different from the modulo operator, because they differ in how they behave when you use negative numbers. For the length, it really does not matter whether you use rem or mod. Either of them behave the same way. If you want to get a little bit deeper into all of this, I can recommend that you watch yesterday's episode. There's a whole bunch of things where this becomes specifically relevant, and where we mix some of them as well. I mean, yeah, this is a pretty straightforward approach. I like it. That's nice. Do you have an idea of like how long this runs for you?
It was fast enough. It was. Let's go ahead and run it anyway and see. Make sure I've got both the test and the input. And let's see. Debug mode is off, just so we don't print too much. And Yeah.
Yeah,
So that's
pretty quick.
Yeah, fast enough.
Oh, very, very nice. Very cool. We can compare this. I do also have a little solution here. Just make sure I pull up the right thing here. A little reorganization on my tabs. Whoop. Here we go. That's my screen right here. And I think the approach is pretty much equivalent. There's a couple of things that I did slightly differently. I decided to just create the ranges and not materialize each of the elements in my range. We're using path instead of file. Now in 2025, I have decided it is time. But yeah, we're just splitting those into like the lower and upper bounds, and we are feeding that into our part 1 implementation. And I just kept a counter going as I iterated over each range and then over each ID as part of those ranges. Apart from that, the approach is exactly the same. If we do have something that is that can't be split in 2 halves, we just continue. Otherwise, we take the first half, then we take the second half, and if those 2 are the same, then we just add it to the sum.
Well, take last. That's I did a drop there instead of take last. That's interesting.
Yeah, I had also I had briefly considered it, but I got real scared with the indices. I was like, maybe I'll accidentally have like an off by 1 if I like it's length and a half, so dropping length and a half should also work. But yeah, this is always with slicing. I try to be like very, very careful, and yeah, it seemed idiomatic enough.
Yeah, that's great.
Probably the implementation of this. No, it does actually use substring. It does not just do a drop drop with length minus whatever n is. There's a question here: why path, not file? Both of them work perfectly well. The reason is just that this comes from the new IO package, so it's considered slightly more modern. We are not doing any of the fancy file system magic that you could do with paths. So for all intents and purposes, that can be considered equivalent. But yes, path is 2025. Yes. So yeah, it's pretty straightforward. I have not spent a lot of time optimizing this part either because yeah, I think there's more stuff we can discuss. I'm not a particularly big fan of my solution here for the first part because there is just a variable and there's a bunch of for loops, and most importantly, there's a whole bunch of like primitives. Right, there's like a list of pair of long returning long. This all seems like stuff where maybe we could have ever so slightly more information, but at least for my solution, I decided to save that for part 2. Any more interesting things to talk about for part 1, or are we moving on?
I think that's good. I think we both did a pretty similar approach here, just slight differences. And I was honestly quite satisfied with just being able to do such a simple solution for it and not having to get too creative.
Yeah, absolutely. I mean, it once again shows that Kotlin, it really has this versatility of like, if you just want to write some code that's simple, imperative, and uses loops, that works very well. And as we'll see in a little bit, hopefully as well, if you want to write some code that is more functional or less mutable, that's also something you can do. All right, time for part 2. Let's see if those arranges come to bite us. The clerk quickly discovers that there are still invalid IDs in the ranges in your list. Maybe the young elf was doing other silly patterns as well. Now an ID is invalid if it is made only of some sequence of digits repeated at least twice. So 1 2 3 4 1 2 3 4, that's 1 2 3 4 2 times. 1 2 3 1 2 3 1 2 3, that's 1 2 3 3 times. 1 2 1 2 1 2 1 2 1 2, that's 1 2 5 times. and 1 1 1 1 1 1 1, which is 1 7 times. They're all invalid IDs. Now for the same examples as before, 11 through 22 still gives us 11 and 22. 95 through 115 now has 2 invalid IDs because 99 and 111 are repetitions. For the next range, we get 999 and 1010, and so on. Adding up all of the invalid IDs in this example produces, once again, a very large number. By the way, which was maybe worth noting as well, I think someone mentioned earlier that they used big integers for their solution and then downgraded back to longs. Indeed, an integer is not enough to store this kind of information. We kind of glanced over this, but longs are perfectly serviceable in this context. Okay, very good. So, part 2, slightly more complex, perhaps. What were your thoughts, Dave?
Yeah, really, the question on part 2 is always just where is the complexity going to be added, right? It's almost always the same kind of situation as the first part of the puzzle. You got the same input that you're working with, but it's just like, what is the little spin that they're going to put on it to add a little bit more complexity? And so here it was in one of the spots that I kind of guessed it might be, which was the, we're not just going to take 2 halves of it and compare. We now need to check for more smaller sizes of chunks that could repeat themselves.
Mm-hmm. Yeah. And yeah, my other worry would have just been that they do some sort of magic for just making the ranges a lot larger. But luckily, the input ranges stayed the same. We just needed to kind of have a slightly different twist on how to perform the actual solution. Okay, let's jump back over to your screen and let's see what you came up with.
Yeah, sounds good. So here's
we go.
Part 2, and you can see one of the first things that I was interested in was finding out what is the maximum number of characters that we would be dealing with. So like how long, how many digits is the longest number that we've got? For my input, it turned out to be 10. I don't know how that worked for everyone else. And so that kind of told me, okay, this isn't going to be too bad. It's going to be maybe 5 times, up to 5 times longer, I guess, if we're having to compare sizes of 1, 2, 3, 4, and 5 is pretty much what we're looking at. So you can see I started off with a very similar structure here. I've got still the invalid IDs object and a loop that I'm going to use over each of the IDs. And I still convert it to an ID string. And then you can see I get the maximum chunk size, meaning what is the maximum size that we're going to compare to see if these little pieces are the same. And so if we have, say, up to 10 digits for this number, for that 10-digit number, we would have a maximum of a chunk of 5 because we'd have at least 2 things we're comparing. Yeah. But we could have as little as 1, right? So that's why we're starting with 1 and working our way up to whatever that chunk size is. And believe it or not, we've got a function called chunked in the standard library, which is exactly what I was looking for. Although I do occasionally forget about whether windowed or chunked is the right one. So it took me a moment, but yeah, chunked is what we wanted here. And then really all I had to do from there is check to see if all of the chunks that we got out of that string were exactly the same as the very first chunk in that list. And so that's what we're doing here is we're just checking to see if all of them match whatever the first one is. And if they are, then it is indeed invalid. I've got a little debugging line here. And then if it is invalid, I simply add it to the list of invalid IDs, and then I break out of it because we don't need to do any more chunk comparison for that ID. And otherwise, it's the same thing. We've got the sum at the end here, and I'll just go ahead and run this one too and just see how long it takes. I don't think this one it was a little bit slower, but I don't think it was too bad.
Let's take a look.
Yeah. So even with the extra comparisons that we had to do, it really wasn't too bad.
Yeah. So a couple of interesting points here. First of all, yeah, you mentioned chunked is the right thing here because So the two functions we have, right? It's windowed and chunked. Windowed puts a sliding window over something. So you kind of get overlapping windows step by step. But here, what we really just want to do is we want to grab, like we literally just want to make a cut every n characters, and then we want to compare whether all of these cut groups are the same. And yeah, so chunked is a really good choice here. It's also very smart to have a break if your chunk is actually considered invalid, because, as you might know, an ID of like 1111 that can either be interpreted as, well, it's a pair of 11 and 11, but it can also be 4 individual ones, which would also count as a repetition. So this is an easy way of accidental double counting if you don't have that break in there.
That's a really good point. And that actually didn't even cross my mind. I was more just thinking performance, but you're completely right that would actually result in incorrect output.
Yeah, I remember that this was something that as I was typing it out, I was like, that's something I should keep in mind. And there is one point here that actually it just came up in chat as I was leading up to it, and it's a point of discussion, which is, I really wish we had a slightly nicer way of checking whether all chunks are the same, whether all elements in a list or in a set are the same. You are using the syntax of using like chunks.all and then just comparing each one of them with chunks.first, which works, but like from a vocabulary perspective, I wish we could express this a little bit nicer. There is the alternative approach of calling chunks.distinct, and that effectively gives us a new hash set, which, of course, if everything is the same, that's going to have size 1 because we only have one distinct element. So that works, and you can compare that size to 1. That is an approach you can do. The problem with that, or, well, I'm not sure if it's a problem, but that does allocate an extra hash set, and it does have to iterate all of the elements to actually generate that set, which might have like 1, 2, or more elements. Whereas the version with all, it can break, like it can do an early termination. So a tiny performance optimization there as well. Oh, very nice, very cool. But overall, I think a pretty straightforward solution. Yeah, using the important essentials. I like it.
Yeah, and this is, again, I feel really good about the idea of always just kind of starting with the most straightforward approach, even if it's brute force and you don't think it's going to work out. It always seems like it's usually good to start there for me.
Yeah. I'm curious, did you iterate on this solution, or did you end up with this one?
This is pretty much, like, I really didn't change too much after the fact. Kind of once I got it working, usually that's the way it goes, right? You kind of get it working, and then you say, okay, what can I kind of improve on this? Yeah. And I really didn't iterate on it too much. This is pretty close to what I started with, other than the one extra complexity that I mentioned before, where I had originally read a map instead of a flat map. These guys, so.
Okay, very nice. Well, let's compare it, because I kind of went a little bit off the rails this morning, trying to kind of also see if we can maybe approach this in a slightly different way.
Yeah, let's see what you got.
It's gonna move us over here again. Also, let's just check here for a second. Isn't that small set internally just an array? Yes, but I mean, effectively, but you still have to kind of do the allocation. So if you could avoid the allocation, that's always nice. Okay, part 2. This code should look quite familiar. I don't think there's any big surprises here. So we still just have a counter. We iterate the same way, and wouldn't you know it, we use the chunked function. And we go for all the segments, which are between 1 and length divided by 2. And, well, we just have a slightly different way of counting of determining whether all of the chunks are indeed equal, using distinct and count. So that part so far, I think, not a lot of changes here. Now, I wanted to break this up a little bit as code that I would consider slightly easier to read, even though the shape of the code changes a little bit as such. So the way that I kind of approached this was, first of all, we do have our ID ranges, and I really just figured, at the end, I want to sum up all of my invalid IDs. So I knew that I wanted to have this return line at the bottom. So now I just needed to do some sort of pre-processing to actually get there. So I created a function called invalid IDs for range. This one just returns us a list of all of the invalid IDs. And here, what we're doing is we are creating an int range from lower bound to upper bound, and then which is effectively just allows us to iterate the entire ID range, and then we filter. We're looking for all of those IDs that are invalid. The logic in here then is pretty much the same. We grab ourselves the string, we grab ourselves the segment length, and then we do the same chunked check. But here we're using the any function because we're effectively just saying, if any of the segment lengths that we might have, if any of those result in chunks that are distinct, or in chunks where all of the elements are the same, then we consider it as part of the filter predicate. And if not, we drop it. So this is just a slightly different way of expressing this. If one wanted to, one could, of course, very much code golf this by inlining this property, turning this into an expression body, doing the same thing for these segment lengths, so inlining this. I'm not sure if this becomes any more readable. It certainly looks a whole lot smarter, but certainly not. I don't like looking smart. I like things that I can still read. So this was kind of my approach here. I also decided. I mean, I don't know. Do you find this readable, Dave? Do you have opinions here?
Yeah, I think it's great. I think it's very readable, and it's just kind of breaking it down. You're really just kind of extracting the logic for finding invalid IDs and putting them into the range. So yeah, I like it. I think it's great.
Yeah, we're just whenever I see the opportunity to use a filter or an any, I try to throw it in there as well.
Yeah.
I did also then think this still does suffer a little bit from some primitives here. Not sure why many people do functional programming and code golfing at the same time. Because it looks smart. Don't tell anybody. But yeah, so I also decided, we could of course do things like create ourselves a couple of helper classes, like upper bound and lower bound, having those encapsulated in an ID range. And then in theory, I suppose we could also provide a JVM inline value class for individual ID, and then that might wrap an ID as a long. This is something that we could do to kind of change up some of this code. It's just that it requires me to move from a filter to a mapping function. I don't want to do that, but it is a possibility. Overall, apart from that, I think not much has changed in this sample. I did decide, we could always, through the power of extension functions, instead of having distinct size equals 1, we could have this extracted into an all equals function that returns a Boolean, and that is just expressed as these 2 lines of code, right? I always like having a good base case. So if it's empty, then everything is true. And yeah, we can return whether all of them are the same as the original one. Yeah. So this just kind of like adds some types or an additional type. We could do more, but the question is really whether for a small case like this, it's worth this extra case.
Sometimes I've wondered if, like, so in some years past, I've tried to structure my code so that if I were to look at just the code, that I'd be able to kind of reverse engineer what the challenge was. You know, I kind of feel like that would be like if I've expressed the code that well using real types, you know, like you're doing kind of here for invalid IDs or individual IDs and all that kind of thing. Yeah. Like if you could look at it and kind of tell roughly what the puzzle was, I feel like that's kind of like you've really done a good job expressing what the code is. But, you know, obviously if you're working for speed or just trying to solve the puzzle, that's not necessary.
It is one of the reasons why despite oftentimes I have variables that are only used once, I still love introducing like intermediate variables because it allows me to just assign meaning to things, and I think it allows me to walk through my chain of thought a little bit more clearly again. Because while I might be able to recognize that this will effectively be the length of the segments, if I just have between 1 and ID length, ID string length divided by 2.any, and then I see that I turn this into a segment length, that's slightly more difficult for me to read at times.
Yeah, I think expressing, like having a well-expressed code is always more important. Like expressive code is always more important than just having something that's like very concise, right? I think sometimes, like you said, you can come out looking smart to your peers with very concise code, but really the goal, of course, is making it easier for everyone to be able to read that again later.
There's an interesting discussion going on in the chat here, which is, of course, whether this base case is even necessary, and I would agree with the chatters that it most likely is not. It all comes down to what happens with all on an empty list, right? And the beautiful thing is that if we do read the documentation here, we can see that thanks to the power of the vacuous truth, if the collection is already empty, the function does return true. Why? Because any predicate is always true if you have no elements to check it against. What a great time. This is a great way to point this out. So we can indeed turn this entire thing into just a single line that looks like this without changing its functionality. Good points both on Aneroid and on Jonathan on this. So both of these work. The other point that is mentioned here, I think yes, but it depends on what the compiler does. The first might throw an error. The good part is that if we have no elements, then this lambda will also never get executed. So this is still valid and will not see a runtime crash either. In fact, I'm so confident in my in this statement that I will run I press debug, but I'll debug the tests, and they should not explode in our face. Should have just ran them by default rather than under instrumentation, but very good. And here we actually can also see a tiny bit of an idea of how long these things take, at least with my machine here. Part 1 finishes in about 115 milliseconds. Part 2, kind of chunky. At 1 second and 800 milliseconds, it's considerably longer. Typically, when I see stuff that runs for a second or two, I start holding my breath, because that's typically an indication that I might have chosen the wrong algorithm. Here, however, I honestly have a hard time coming up with a better algorithmic solution for the problem. Like I've also debated this with some colleagues. While there might be some ways of like perhaps pre-generating some patterns, or maybe relying on a regex engine, which
that's what I was going to ask. Yeah, I was going to say if anybody in chat did a regular expression solution to it. I'd be interested to see that, because that does kind of cross your mind as a possibility, especially if you've got a limited size, like limited number of digits for these.
Absolutely. Regex is what many did, including I. Okay, very good. Very cool. And Rob mentions that segment lengths can be filtered for whole integer divisors on the length for a minor optimization. That makes sense, because if you can't actually chop up the entire thing, like there's no point in checking chunks of length 4 for a string of length 10, because there's no way you're ending up with the entire string. So that makes sense. So I mentioned that pre-generating improved my performance greatly. Okay, very interesting. So just checking against a list of pre-computed. No, that's and that's also I'll throw this regex up here on screen for a second. It's a very compact solution. You'll love to see it. So this is we have a capture group, which is any number of digits. So we got \d, which is the digit character plus, which means like one or more of them. And then I'll be honest with you, I'm not that good at regex. Correct me if I'm wrong. I believe this means considering the first capture group, so \1, the first capture group, one or any more times. Is that? I think that's
I think that's right. Yeah, I think it's that the first group, one or more, like beyond the original group, one or more times, right? I think that's what that is. Yeah, that's really concise, really man. That's really good.
That is really, really cool. I think we can also just check this in theory for a second here. So if I just were to type this out with a \d plus \1 plus, and then I type a 2 regex here, this should be highlighted. And then if I use the check regex, if I type 1 2 3 1 2 3, that does indeed work. If I type 1 1 1 1 1 1 1, that also works. Wonderful. 1 2 3 4 1 2 3 4 works, but 5 does not. A wonderfully concise solution.
Yeah, love it. That's fantastic.
That's really good. That's really good. Also, 26 minutes runtime in C++. I think you might still have a tiny bit of optimization to do on this one, I'm afraid. Unless you meant 26 milliseconds, which who knows.
Or was that how long it took to code the solution? I don't know.
Oh, yeah, who knows?
Yeah.
How did I bring up that regex tester? So when right here, I have a regular expression object, right? So this is just it's a raw string. By calling to regex, IntelliJ tells me that this is indeed a regular expression, and I get syntax highlighting. And then I just hit Option Enter or Alt Enter. And in my context menu, I get the check regex pop-up menu. And here I can type something in, and it will give me a little check mark if everything is okay. It's very useful. It's very nifty.
Yeah, how many times have I gone out to a website to try to do that thing when it's available right there in the IDE, huh?
Yes. I'll be quite honest with you. So I first learned writing regexes on rubular.com, which is a Ruby regular expression editor. And I still sometimes find myself going back to it. Because it does have one feature that I really wish we could get in IntelliJ, which is that it does also show you the match groups, which is which can be incredibly useful if you're doing some. Let's be honest, if you're parsing HTML using regex, like you're not supposed to do. But every once in a while you just need to do some data extraction. But yeah, for most cases, I mean, it's just so good having it right there. There is also the ability to just edit this regex fragment, so it actually puts you in a regex specific editor. The best part about this, as far as I know, is that if you type anything in here, it will also take care of any of the escape syntax for you. So I'm pretty sure that if I put okay, not sure about that one.
It
But
is. I was gonna say it is a little bit better than like if you're doing single double quote string, like a regular string for your regex instead of the way you've got the like triple quotes going on there. I think you're right. I think it does get rid of those extra backslashes for you.
I think it. Okay, hold on. Let's see this for a second here. If we go back here, we edit this regex fragment. So yeah, so we can see that down here in the editor, we're only seeing a single backslash, but then it's inserted correctly using the correct escape sequence. Yeah. Very nice, very cool. Sweet. Jonathan says regexes for me are I guess lots of times never read it again and just hope it does what the name suggests, and if not, guess again. There have been plenty of times where I, at least where I was at the liberty of doing it, I looked at a regex. I was like, this isn't exactly doing what I want again. I'm just gonna rewrite this from scratch because it's gonna be easier than trying to decipher all of the little artifacts or the little tricks. But this is a very lovely like a very compact solution of checking this property. So kudos, very, very good. There is an important point, and I'm not sure if this is also the reason why you got a 26-minute runtime in C++, but it is always important to note that constructing a regular expression, like calling to regex, for example, it calls the compilation for the regex. So it does a regex compile where under the hood it actually creates like a state machine to make sure that the regex executes really fast. But it also means that you should not continuously construct new regexes in a tight loop, because if you do that, you're just wasting cycles recompiling things. You might be able to like pray that at some point maybe the JIT realizes you're just constantly compiling the same thing, but I would not rely on it. I wish there was a caching mechanism or something built in, but really, like, you can just extract these as like file level constants, and that should work. That should work all the same. Very cool. Very cool. I did still want to have some performance optimization. And since I could not come up with a good way of fixing my algorithm, I did my patented move of just approaching parallelization, which effectively means I just built the same implementation using coroutines, which does actually boost the implementation or the speed by quite a bit. So once again, if we run this here, we take a look at the execution speed. Part 2, between the different ones, we're getting around 1 second, between 1 second and 1.5 seconds of execution time. If we do some parallelization, then we can push this down all the way to 360 milliseconds, which is not significantly faster. It's at least 3 times faster-ish. The code for this, thanks to the wonders of coroutines, is quite compact. The first thing was just I made sure that I had the coroutines dependency in my project. I made sure that my main function was actually suspending. And then I just changed the implementation of my part 2 to, instead of iterating over things the naive way or the straightforward way, for each of the ranges, I create a new coroutine. So I start this using the async coroutine builder function. Inside of that coroutine, I still just compute all of the invalid ID ranges, but I do all of this, well, on the default dispatcher. So this means that all of these jobs are created and then executed on a thread pool that has as many threads as I have CPU cores, which in my case is, I think, 12 or so. So it means that I can process up to 12 ID ranges at the same time. Then, of course, at the end, we still do have a sum that we need to calculate. So we do need to wait for all of the results. Once we have those, we have a list of lists. So we flatten those. So we flatten this list of lists, and we sum it all up. And that's pretty much all there all there is to it. So the real change was adding the suspend modifier here, making sure that we have a coroutine scope so that we can start multiple coroutines, and then wrapping this part in an async block and making sure we wait for things. So with very few changes with no changes to the logic and with very few changes to the overall code, we managed to just use more of the cores. Let's benchmark your solution again. I unfortunately I don't have a Kotlin X benchmark setup. Unfortunately my day was busy enough that it did not allow for this extra excursion, but we do see that we've got a 334 millisecond execution here versus the slower ones. So yeah, best I could come up with, but it's the patented move for when the algorithm is just a little bit too slow for your taste.
Just run it in parallel, huh?
Yeah, I mean, to be fair, if it is a task that is well parallelized, it'd be a shame not to use all those wonderful cores that are just chilling, right?
Yeah, and like you showed here, there's really like a little bit of change to the part that wraps the core logic, but the core logic itself, especially the way you structured it, ended up really just staying the same. So it works really well.
Absolutely. We have someone here saying that you can just wrap it in a measure time. I did actually also do this. We can see here, I'm even using the measure timed value function, which is my favorite because it returns you two values. It returns you the actual value and the execution duration. So we can once again see here roughly on the order of magnitude of maybe 400 milliseconds or so. Of course, this is not a good benchmark because we're not taking into account the just-in-time compiler that will make our code hopefully significantly faster. So we can run this 100 times, and we can maybe get a little bit of an idea of whether it gets any significantly faster. And we can see that over time, if we're scrolling up here, we can see that the first execution, it might take up to like 600 milliseconds or so, but then very quickly, without having any kind of caching, we're consistently below 300 milliseconds. Seems that we've kind of like settled in here on like somewhere in the 260s ish. So yeah. Yeah, so this is the layman's benchmark. I'm of course hoping that maybe on one of these future days, perhaps we might be able to also explore a proper Kotlin X benchmark implementation. But we'll do that. We'll do that in a future episode. Yeah, the first ones can be considered as a warm up. But yeah, if there is a problem that falls kind of into this range of, well, it's just slightly too slow. Sometimes just throwing brute compute against it is just enough. And sometimes you do the math and you realize it's going to take like 200 years regardless, even on 12 cores.
Yeah, there are definitely some puzzles I've done in the past where it just I could tell it was not gonna happen in my lifetime.
Maybe that's the time where you just need to start phoning up the friends at OpenAI or Anthropic and see if you can just borrow their cluster for a minute or two.
Yeah, really, all that RAM. Yep.
Yeah, I'm sure it's gonna chew through all those things and no problem. Yeah. Is also another mention here in the Kotlin Slack channel. There are people generating repeats rather than brute force, and there's folks who solved this in less than 10 milliseconds. That sounds very, very cool. And there's apparently even a solution in around 60 microseconds. No, that's still milliseconds. Sorry, still milliseconds for part 1 and 2. By iterating each potential subsequence and then repeating it n times before checking it's still in the required range. So rather than, this is essentially putting the problem on its head. If this is something, if these are solutions that you'd like to dive into, it is microseconds. Sorry, wow, my bad. That's fast as heck. If those are solutions that are interesting to you, we are unfortunately out of time for today. Careful, flashbang. But we do have the Kotlin Lang Slack, where we have these discussions and where the folks who have done the ingenious solution of generating these things in advance have also shared their solution. So if you want to find that out, you can either just browse it on the web, or you can also hit the join Slack up here, and then you can just join it like a regular workspace. You can drop in your own comments, and yeah, you can participate in each day's discussion. Very good. Okay. Dave, any closing thoughts?
No, I think I guess I'm kind of wondering where they're going next with the 12 days instead of the 24. I assume, kind of like you were saying before, that they're gonna still kind of ratchet up the difficulty to what it had been, but just in 12 days instead of 24. So I'm kind of wondering if we're gonna get to maybe some like map traversal and things like that. I think that's usually about day 5 or 6 in the past is kind of when we start getting there. So maybe we'll see that happen here in the next couple days.
I'm very curious to see how things are going to go. Do you have any predictions specifically for what might happen tomorrow?
Well, I think we're probably going to get at least one more day of some kind of like just solvable with kind of like we've been doing yesterday and today, with just kind of straightforward approaches. Maybe the second part will be a little more difficult, where you won't be able to quite brute force it. And then I think we'll probably get to some of the, I think on Thursday is probably when we'll start seeing more of the maps and navigation, where, how many times do I have like a grid style solution? So I think that's probably going to be we'll have one more day of kind of what we've been doing, and then I think we'll start getting into more of that kind of stuff.
I'm curious to see if we're gonna see a problem that uses numbers using different base notation, perhaps. I recall, I believe it was an airplane seating chart perhaps problem, something like this that ended up being the interpretation of like a multiple binary strings, and having this like specific aha moment of saying, oh, this is just the binary string, so I can do all the things that I can do with a binary string. That was like the key point that allowed you to kind of like break through the problem in a nice way. So that was one of the problems that I don't even know why, but it really stuck with me. So I'm still like I'm always anticipating like the revenge of that particular puzzle. We're also seeing here text-based puzzle tomorrow, repeated hashing one. Yeah. So we'll see. So we will be returning tomorrow on the same channel as we are on here right now. YouTube.com/Kotlin. And of course, if you don't want to miss it, make sure you hit this notify button. There's one important note. Tomorrow, we will be starting half an hour late. Why? Because Marton, who you saw yesterday, together with my lovely colleague Pamela and some really esteemed guests, is going to have a live stream happening on how you as an Android developer can advance your career using Kotlin multi-platform. And I'd reckon even if you're not an Android developer or not an Android developer yet, the story of Kotlin multi-platform is one that I think is particularly exciting regardless. So, you can tune in at 5 p.m. tomorrow. Make sure you grab your notifications for that as well. And immediately after that, we will be back with Advent of Code Day 3. All of the other information you can find on our blog. And of course, I very much invite you to join our Kotlin Lang Slack channel as well. Dave, it was really, really lovely to have you here.
Always a pleasure. Yeah, thank you for having me.
Much. It's really good. The question is doing all 12 days this year. Unfortunately, we will only be doing days 1 through 5. But I think it should still be a great time. And there's still a couple of guests, so make sure you do come back. Are you going to be diving into tomorrow's task tonight, or are you going to be sleeping, like getting a good night's sleep and then tackling it?
Yeah, for me, I think I'll get a good night of sleep and see if I can tackle it with a little more focus tomorrow.
Very good. Okay, well then best of luck and have fun, of course. And I hope that I'll be seeing all of you tomorrow after our wonderful other event. Thank you so much for tuning in. Thank you so much for participating. And have a lovely evening. Take care, everybody. Bye-bye.